Hello. So I'm back again. I'm going to take another stab at the activity pane and see if we can make some progress. So last time we worked on adding a context field to the activity pane, and this time I'm going to see if we can make it a little faster. So I have a new recording, and this one is much bigger than the marionette wires project. See, like, it's huge, and it actually took us like a couple seconds to load this. And that's what I want to fix. You can see that the recording has multiple actions, and each action's really big. And some of the stuff was detached, which is cool. So that's one thing we added, like just showing the context as detached in red, and then the region name if it's still around. But it's slow, and that's annoying. Now, there are a couple ways to approach this. What I want to do first is see if showing just a collapsed tree will speed it up. It's a little bit naive, but it'll give us some insights into like what it's like to add a bunch of views and then attach them to a hidden element. I believe it's going to be fast because the browser doesn't have to do a relayout or paint. But if it's still slow, we can dig into why that might be and see if we're doing too many renders or if there are other costs associated with some JavaScript, whatever. Anyways, so how do we tell Marionette, how do we tell the app to render these in a collapsed fashion? Let's see here. I'm just gonna get everything set up. And this is the inspector for the inspector, which is so much Inception, I love it. And then jump over to the tree view and we'll see if we can collapse it by default. I've got the project right here, and I'm just going to create another branch, just call it activity wow2. It's going to be based off our previous work. You'll see that we're using a local replay in the sandbox because I want a much larger recording. Getting the environment set up, we're going to go to the JavaScript, inspector, app, not UI, activity tree. And when it's shown, we want everything to be collapsed. In fact, I think the layout is showing the tree, so let's take a look here. And I think there's some logic, yeah. So I had this up initially, or Ian had this. Basically, we collapse it and then only expand the root. We'll only show the first level. And we could play with this. Maybe we want to like show one level if it's fast. I don't know. I assume we're going to have to iterate. Anyways, hopefully this will render with just the actions being shown in the activity pane. Even the UI tree is slow too. Like, I wonder where this lag is coming from here, because I can't click on anything. It's still rendering. So that's a little frustrating. Notice how that just updated. Now we're waiting 1 second, 2 seconds, 3 seconds. It's still not being shown, so there's some performance issue. Still at play. Okay, that's ridiculous. Look, we're still waiting, It's not much faster. Click over here, that's pretty fast. And these are all collapsed, so once it's in, expanding and collapsing is no big deal, but getting that initial load in there is slow. So what I like to do at this point is just to get a lay of the land and do a CPU profile. It's just one way of seeing what's expensive. So start that up, refresh, and we're going to see first where the time is spent on the UI pane, showing this UI tree, and then the activity tree. And you'll see the flame chart. It's going to be huge. Seems a little bit different. Well, I guess it's still taking some time. Just waiting to see like when the cursor shows up, because that's a sign of lag. All right, cool. So that's in. Now we go to activity. 1 second, 2 seconds, 3 seconds. Now, I used to want really short profiles, so I can have a really focused flame chart. But recently, I've just kind of gotten the habit of making fairly large profiles because, you know, you have more data points, you can compare, see what's happening, and I'm just going to like show the UI tree one more time. All right, and things kind of look pretty good here. Now we just want to see where the time is being spent. And there are a bunch of ways to do this. I like looking at the flame chart first just to see. So 5 seconds were spent up here. Look at this, by the way. It's huge. We're pummeling the CPU. And that's another thing with these profiles. It sometimes takes a while. Okay, so a bunch of different spikes. Update nodes. This is clearly a tree thing. It's pretty deep. Extend. Creating a bunch of nodes. This looks like it's going down the tree and creating all these things. Oh, fascinating. Serialized object properties. I wonder if... I'm just going to speak out loud for a second. I wonder if we're tracking the performance of this inspector. We did turn that on as well. Yeah, it might be different if the marionette inspector is not on, but say la vie. We'll take another look at this and then go back. Look how huge this is. This is just so nasty. I mean, this is also interesting. Show module being called twice. 4 seconds. Index show module. Run module. I would have thought this would all be one of them. I want to see what this radio is. Radio command. So we're calling show tool. 1, 2. Would you have? I did not realize we're calling show tool so many times. It's kind of interesting. And this one takes 4 seconds. This one takes some amount of time. What if we're trying to do the same work multiple times? All before show. Like, it definitely looks like we're trying to do this multiple times. Render children. I want to confirm that this is all fit activity pane. Because nothing in here says activity pane. These are left kind of like believing that it is. Show module, show tool. We could just log show tool, and the next time we do a run, we're not going to use this inspector because I think it slows it down. You can even turn on logging entirely, or just, yeah, let's turn on logging entirely. So just turn on app logging. And close this so the inspector shuts down, open a new one. Now we're not going to turn the marionette inspector on because that I think was going to slow it down. We saw some of the inspector stuff in there. So it's loading. App tree shows in. Activity tree. And now I'm just going to watch and see how many times show tool is called. Just once. Show UI. Show activity. Funny that it's only one action. I'm forgetting everything I wanted. Before there were multiple actions. Huh. Well. Inspector page URL change. These kinds are kind of funny. So we showed the tool UI twice. Now we're waiting for activity. Still waiting. It's the kind of thing that I'm suspicious of. Yeah, see, there are the two actions. Go back to UI. Oh, still rendering? Alright, fine. So this is the huge part. This is 10 seconds, and we've got to figure out why that's taking 10 seconds. Because that's unacceptable. So big. It's so big. What's going on? Run module index. This show tool. Maybe I'm just making too big a deal out of the line here. I don't know how to make sense of show tool like seemingly being called twice. Just can't let that go. Just looks like it's being called so many times. This is so repetitive. Just like show tool, show tool, show tool. Sorry about that. Before show, show. Collection render. Alright. So we've done all these things. Kind of an idea that like we have no ideas. I have no idea why it's taking a while. So we'll just jump to the next thing and just see what's taking a lot of time in total. Here, I like to just like look for something specific. Add child view. Maybe there's nothing. 26% on show collection, render collection, render children, render. I like that everything's on before show because that's gonna affect DOM mutations. We only really want to do one paint. Maybe there's some more ways of auditing this thing. In her yard in Brewster, her daughter came home from a party and found her. Same way as my uncle, bleak. The next thing I want to kind of do is going to be a little bit of a long shot, because looking at the CPU profile, it looks like things are fairly standard. It's hard to get a sense. Maybe we can do something that will look at how often a layout happens or there's a DOM event. I've got some code I'm going to paste in that will show us some of this stuff, and we'll put it right here, and you'll see what we're doing. So I want to get an element. So I'm going to grab the activity lists EL. And we can step into this code. And I want to observe all DOM mutations to that event and just console log them. And which ones are we going to get? We're going to get attributes, child list, character data. So a lot of things. And then observe that stuff. It's just like an interesting approach that might yield something. Of course, I fully expect the child list to be pummeled, but maybe we could see something interesting just by logging what's happening that we can't see by traditional methods. I'm just so broken up about it. How is it that this sad history repeats? I'll return to Ohio, to the place I was small. Gonna see where I'm with my cousins and play with them in the snow and fished in their ponds. Gonna see how they've grown, visit some graves and say, hey, I've missed you. Gonna find out as much as I can about my little second cousin. Gonna go to Ohio, where I was born. Got a 10:45 a.m. flight. I'm leaving tomorrow morning. Gonna see my aunts and uncles, my parents and sisters. Mostly I'm going to pay my respects to my little second cousin Carissa. So a little cleanup for this inspecting code. I think it's just because we're trying to do an initial activity render before we do anything. Should now redirect to UI and then we'll jump back. Alright, cool. So do we have a target? Guess not. Oh, we can probably ensure that there's an element. Go radio, go back. She was only my second cousin, but it don't mean that I'm not here for her or that I wasn't. Alright. What? Region. Ensure. Now, do we have a target? Yeah, we do. So just add that line up here too. Anyways, were there any mutations? Oh. Child list. Yeah, I bet it was removed. I'm just gonna refresh so we get those region and sure element stuff in there. wiring it up. Look at these mutations now. Mutation record. It's kind of cool. Added nodes. I like this a lot. It's my first time using this API, so. There's an M. We can play with this. M.added nodes, remove nodes, target. Look at that, it's only adding an empty UL. Child list, oops. Wonder if you can observe more things. Got this from over here, so they were just saying attributes, child list, character data. I wonder what other events you could listen for. Subtree. That's really what I want. I can explode now. Because I want to know every time there's a subtree change. Okay, that's more stuff. What are we getting out of these things? I want to watch expression, scope variables, sure, mutations, added nodes, that's good. Type, child list. Type attributes, type attributes. You know what, let's print the type as well as added nodes. So now we'll see kind of like what we're doing here. And I'm going to just look at the first one because I think we really only have one element here, and this is probably more generic. And let's get rid of this, just so we can see what's going on. So attributes. Oh, and I like adding bang, bang, bang. Just so I can filter, because there are other things coming in as well. Right? Maybe? No? Oh. Attributes undefined 1,000 times. Child list. Looks like it's there, but that might just be a reference thing. 2,000 attribute changes? It's nuts. Let me just do some stuff in here. I love using these. Child list. Added nodes. Attributes. So this is one that's probably following the same pattern. Oh, we can look at attribute name. Namespaces. What's that? What else do we have? New value, old value. Value, do we have any of that stuff? Like a target. I bet we're expected to look at the added nodes. No, maybe not added nodes. Maybe target dot attributes. Let's just planetary as well. I'm looking for a good way of like grabbing the class. Get named item. We can try mutation dot attribute. It's kind of not what we wanted. Put that into here. Oh wow. So yes, that is what we wanted. What's different? See, so we're looking at a class list. I think. I don't know, what are we looking at? Oh. Some kind of tree outline. Name, let's just see. Tree group is expanded. Okay, so we can probably. Now we got something. It's just really long. Alright, so the reason why I want to drill into this is we have a lot of mutation events, attribute events. So now we can just see class, target, and value. This is another attribute. It's kind of interesting that we're going through and what's registering is that adding all these is collapsed values. I don't know why. I wish we had more information about this target. We can play with that too down here. So we can see view 198. First child. Data set. So that gives us the context of these changes. We're literally like running through here and updating each one to be is collapsed. And do we know what the old value is? Is he gonna tell us? Doesn't know that shit. Move nodes. It's like started off open and then we collapsed them. What if we had it collapsed by default? And I'm just gonna write some bad code and we'll see. Tree.html. So I know this is like a collapsed class. Let's Let me do this. No. So that's coming from here, maybe? Oh no, it's coming from the base class. So I'm just using a lot of knowledge that I have about this thing. Is collapsed. So we're just like, yes. And the reason I want to do this is I want to run this test and see if now we have fewer attribute changes. Like maybe if it's always collapsed, there'll be fewer of those. And that's interesting to me because maybe that's the performance. Maybe we're showing it and then collapsing. Still taking a while. Still a massive number. Also, everything's hidden. Childless changes. What do we want to look at for childless changes? Dang. What is there? You'd think it would be added nodes because it's updating the child's. Remove nodes. Oh, it's taking things out. Okay. Let's get out of here. Now let's take a look here. I think we were just leaving activity pane. But we'll see. Okay. So this is a child list. We always saw that. What if we have a call stack here? Not really. I guess it's async. So there are two types of changes. There's the is collapse change. And I'm also just noticing that context. No, the context just jumps along. Tree group is collapsed. Oh, maybe it's still. Maybe it's trying to do this anyways. Because we call collapse in the layout. So like, it doesn't know that it's not changing. Maybe we're here. Release the log, go to UI, don't come back. Now it's just jump to activity. There should be no mutations because it started and collapsed. We're not telling it to change itself. But we'll see. Child list. That's promising. It's done. Okay, so it's those attribute changes that are coming in. So I think this was the wrong way to go. I think when we create the views, we want to say that it should be collapsed. So where's that being set? Well, is collapsed should be true. So let's just like play with that. So what are we looking at here? We have a model with attributes root. I'm going to skip that one because that's a weird one. Model, attributes, root again. Well, maybe we have to wait for a second. I'm just going to go to UI and then let's just release it, let it create all that UI stuff, and jump back to activity. This is probably the root again. See how much practice we're getting with this. Okay, so let's just create some more of these. Expand. No, let's not expand. Let's just look at name. And the other thing we're probably going to want to look at is the collapsed value. Cool. The rest of these are created falses. Maybe we just want to create it with true. So who creates these models and how can we just quickly say that from here? So activity root is going to be one of the models. And that's created here when we build it. Activity node, let's know some of the stuff I didn't write this code. It's built right here. So we could loop through this collection and just collapse it. Frankly, I think we could do something a little bit smarter, because I think the tree model has all of that for us. I think it might be called node. It's like a component tree. Yeah, node. Collapse will trigger collapse. No, is collapsed. Who changes that? Wow. This triggers a collapse, and then nodes invoke collapse. So so that was probably handled by the tree view. It probably has a model event for collapse. I'm going to take a bold step here and say that should also be done in the node. Maybe this is terrible, maybe it's not. Alright, and that can go away too. Alright, so now I know that I can tell the node to collapse and it will collapse all of its values and expand all of its values. Fine. So activity tree, activity layout, so much code. Okay, this is all our target observer stuff, but what I'm thinking is that we really want to collapse it before we show it. Now just expand the root. So now I'm thinking we'll have fewer attribute changes because everything will start off collapsed, but we can also listen to this class name and we'll see. I think getting the mutation observer in there was a pretty nifty trick. I mean, it'd been really hard to see where that was coming from. And we might have actually gone down another path of believing that the JavaScript is causing it with all the render children, render show, all the view creation, and often it's not the case. So it's good to go in there and see. I'll release this. Does this mean that React is better because they bundle all the updates? Yeah. I don't think this would have been a huge problem in React, but then you wouldn't have had as much fun. Class name is collapse true. All these guys are true. It's kind of cool. So I think it's actually here, but hidden. So we can see activity list. Let's just remove some of these by hand. Yeah, it's here. So I think that this expand path root thing didn't quite work. So I'm just gonna do something a little bit different. We can go here. We'll see how to fix that. Alright, so I want the root to not be collapsed. And it's like an activity node. Does it have this collapse? It does. So I'm just gonna do that, but just to see why this wasn't working. You can see what it's trying to do. Trigger, expand, node. Oh, expand path. Didn't get that expand logic. So that thing. Honestly, a lot of this code is quite redundant. It was written pretty fast. I never really expected this all to be around for so long, which everyone says. And I think this is going to work now, so I'm going to bring that back. We can set a breakpoint and see if that works. The other thing is I like root. I don't really know what that's going to try to do, but so I'm just turning this off to go to UI, and then we can turn it back on once we're at UI. That's how fast that is. So expand path, and we're done. It's not so bad. And we only had one of these child list updates. Let's see how long it's taking. Create a profile, go to UI, do any breakpoints? Hopefully not. Profile 2. Still kind of long. It's not like so bad. It is kind of bad, isn't it? Radio. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's long. It's not doing too many mutations. Maybe we should blame JavaScript. Tree. I love how none of this is like activity tree. Like this part is. Serialized event is taking 10% of the time. That's interesting. Request view node is part of that. I don't know. Build view tree. It's kind of funny that it has to build that view tree every time. I bet we could remove that. So it doesn't do that every time you ask for something. Like we could just memorize that view tree and invalidate it. But I don't know that that's really what's caused it. Next tick will require half of our time is spent in require doing next tick stuff. That's troubling. Let's go top down. Go back to the flame chart. Maybe there's no hope for us. You know what? Let's memorize that view tree stuff, because the more we look in here, the more is spent inside of those things. That's just totally wasted. So what's happening, and we did this the last time, is in serialized data, we call serialized event. Serialized event asks whether the view is detached in the name. And that's coming from here, which gets the view node. It has to request this view node object from the UI. And that does it by finding the view tree by node CID. And the UI data is kind of slow at this. It's slow because it has to build up the tree. This view tree, build view tree. Now, the view tree is only ever invalidating when the region tree is set, so we could do something like that. Paste that on, change region tree. Step build view tree. Or better yet, reset view tree. So, when we ask for the view tree, let's give some memoizing, right? That memoizing action in. So when the region tree is set or changed, we clear it. Tons of reactive code. Is this gonna work to speed it up? Honestly, the profile said that was only 10% of a hit. But it does seem expensive to build it up all the time, and you know, I don't have anything better, and I do have 5 minutes, so it's like worth just seeing what happens. Still, it's taking a while. Maybe I'm naive, but it didn't seem so bad. So let's create another profile. We can compare. I love that the UI was not so bad. We can also see, we can see some more data. We can get some more data on like how long these things take. That's really cool that the child list is removed 11111, so that's really slow. So in this profile, it's 8 seconds, and this one, I don't know, going from like 6, maybe even 7,000. Really? Well, I don't know. No, we're going from like 5, 12, so it's still a lot of time. I'm going to point out that for some reason the show tool thing isn't called as many times anymore. I don't know if that's us or if that's just like a weird thing going on. So fractal. It's so huge. Add child view, add child view, add child view. You know what, let's just zoom in like a lot. Crazy. Yeah, all these are kind of the same, so this might give us a better idea on what one of these guys are doing. Just one iteration. So add child spends time rendering the template. And 2 milliseconds compiling. So that adds up. We could pre-compile that. Showing the, okay, so one child first renders the template and then goes into each collection. And then add child, spend 7 milliseconds. Creating a new collection view. All this stuff is so small, I don't really care. And adding its child view. Or compiling. We could speed that up. Looks like we're spending a lot of time in this handlebars project. And then triggering what? We're triggering. This is not optimized. You know, And then we have to do some JavaScript. I think the handlebars thing is our first good lead besides memoizing, which seemed to help, but not too much. This activity tree. So here's our template. And it's just represented right here. So let me do some fun things. I'm just gonna say debugger. And then we can stop and we'll see how to optimize this thing. I like just doing this in here because we can then get a much more narrow idea. Like, you know, you could look at handlebars API, but I prefer just to do it in the command line because we kind of know it's going to be a compile. Parse. So that's that's that. Can we require handlebars? Is that what we're doing? I think that's all it is. If compile, compile input. Here's an optimization. Let's call it C. Compile TPL is equal to handlebars dot compile. Like, I don't know, maybe there's something else there. Like some options that we want, but we'll get a really good idea pretty quickly, and there's no reason to like dig into the renderer that we're using in that strategy. Well, one good reason would be that, oh no, must pass a string, I compile, you passed a function. Yeah, interesting. Did we? Did we really? Let's break on exception. Oh, that's why. So that was in main.js. So we're doing this all the time. So we can just say, by the way, if else compiling. Maybe we want like a caching layer for templates, but like screw it, we'll see. Okay, maybe I just want it to work, but that seemed faster. I mean, not fast, but faster. Actually, a lot faster. Just trying to get a sense. So that was probably like, notice how this came back. By this I mean like the run module, show module. I don't know why that sometimes repeats. But that was like 2 seconds. It's pretty amazing. And it's the same work. And we can do that same little trick where we just jump into like one spot. Add child. Funny. I love how when you get rid of something that's expensive, other things take up more space. In this case, it's a lot of the marionette stuff, render template, binding. Like these are all things that we weren't looking at before because the handlebars thing was taking up so much space. Which is legit. So delegating events is all jQuery, setting up the events. I don't think we're going to speed that up. Render child view, render 1 millisecond. I don't really care about that. Destroy children. That's kind of interesting, but where did I get the real bottom of this thing? Serialized data. Remember our serialized events was something we don't see that anymore because it's really small. Render is amazingly fast. Look how big it gets when you just like blow it up. I'm gonna do another profile. Just want to make sure that this is like consistently 2 seconds. So, I mean, hey guys, I think we kind of got something here. So 3 to 6, 3 seconds, something I'm willing to live with. Remember, we started at like 15 seconds, 12 seconds. Something stupid. What was that? That was like 12 to 20. Well, I guess maybe it's not that bad, but like we went from like 5, this one was bigger, 4 to 14. So 10, we went from 10 seconds to like 2 or 3 seconds. 3 seconds. So that's good. It's real good. I think it's kind of funny that like memorization is not having here. Like, yes, I know this one's slow, so we want to pile it, but what if we just had a cache? Also, maybe we get a lot of other free things. Just destroy your code. I'm gonna call this. So we'll see if this works. I wonder if like having a massive key is stupid. Like, remember this temper's gonna be huge, but maybe it's just like preferences anyways. You know, like a string of memory kind of thing. Uh-oh. Uh-oh. It took a while. We lost our performance when. Pretty sure we did. Sad. Render pile input. Render compile input. Yeah, we lost that somewhere along the way. Template. I'm just gonna like hang out here and see. Oh, we're not actually using the temple hash. So you might have seen that one. Like, stop. You're not using your cache. No. Possible to know what to do all the time. So yeah. So if the compile template is a function, great, use it. Otherwise, set it equal to this. And put it in there. Alright, I mean, pretty code? No. Fast code? Yeah. And you're like, man, you are losing it. What are those square brackets doing there? It's objective C. Why? So now, is there a function? No. Is it a function? Well, actually, I'm not even looking at it too closely. Kind of, I guess, maybe it's still interesting, but is it compiled? No. No. Is it ever compiled? No. What did we do this time? Activity list. Do not render tree item. What's that? What's that shit? Well, whatever. Question is this. Looks very similar. Wow. We got 8 things in the cache. Yet, what we're looking at now is not there. Let's just like check a couple more. Why not, right? Also, like the view, maybe there's like something else we can latch on to. Is tuple cache the same thing? Yeah. It's the last thing in there. What's the last one? Maybe we can cheat. Let's just. I can't remember how to do this. Get this out from that one. Keys. It makes it look like it should be right there. This is really not a thing? No, it is a thing. It's like we're not saving the compiled templates. It's just... Oh. Because it's being run. Oh, you... Oh. Okay, now we have that. And we're going to return... Oh my gosh. Data. Okay. I see. So if it's a function, okay, we'll improve this in a bit, but that makes sense. Sorry guys, that was 5 minutes of our lives and neither one of us will get back. But that's cool, it's cool, now we know. Activity. Look at that compile. Just keep hitting that. That's awesome. Got another audit. No. Profile. And I'm going to say it's faster, but I don't know. We're back to pretty good times. I mean, it's still pretty silly, but given the amount of work we're doing, like listen, we know that we're not mutating the DOM a billion times. In fact, actually destroying it might be worse. It just looks like you're doing a lot of JavaScript. It's a lot. Like each of these things is 1 microsecond, but you know, microseconds bad. jQuery, each of these things. I don't know. Can you say jQuery is slow? It's taking 58 milliseconds. No. Construct. Inner HTML, not slow. This is the thing that people want to say that React is so much better because you're minimizing these hits, but in total it's 28 microseconds. Out of what? Or maybe it's milliseconds, but out of what? Who cares? Out of a total of 2 seconds? So what? I don't know. Okay. Honestly, at this point, I would conclude that if you really want this to be faster, the easiest thing would be to say, okay, well, don't draw a tree with 900 nodes. If you're trying to draw a 1,000 node tree, you're doing something wrong. Maybe we can do some optimization where you only ask the tree to draw the next depth. And then you're bound to like 100 or 50 or 30, some small number, like a constant size, and then you're 3 seconds you're at 300 milliseconds, 200 milliseconds. I think that's probably the way to go. Or like some lazy loaded views, so you only show the views or the nodes that are being shown. But then you're doing a lot of JavaScript computation, and frankly, I don't think that's any more expensive than what we're doing here. Sorry, I don't think it's any cheaper than what we're doing here. Thinking of this stuff like find view. Like, okay, we could optimize that. Remember when request view had that whole build tree in there? But that took a ton of time that we just don't look at now. All right, cool. So let's make this a small commit, and then we'll call it a day. Small commit, maybe not small commit. So is collapsed. Remember the expanding collapsing thing that we did so long ago? Well, there it is. What are we doing here? Oh, that's actually observation stuff, so we probably don't want to add that. That's going to go away. This is important. View tree. This is the memorization, so we should keep that. Template caching, sandbox. That's left in here. We can probably get rid of some things. We don't want to log. Oh, maybe the logging is adding some time. Console logging is usually one of the more expensive things. And this is playing the local sandbox. I'm going to do that, and I bet the activity tree logging over here is slow too. We might be able to go below 3 seconds. There's still something. But I like the log is empty, and you can see how long that takes. You know, just logging out the 900 child node changes probably took time. Just feels a little faster, actually. I guess it's still about 3 seconds. Ish. Thinking, it's funny how you see different things each time. Wow, that's still jQuery and all this advanced stuff just looks so big. What's in here? Listen to. Oh. Collection views are listening to all their events. Let's turn that off. Activity tree has a collection view. So I'm just going to say this is stupid putting the program there, but whatever. Come on. It's funny how long it takes for the debugger to hit. Like, there's a whole overhead to this. Anyways, so this dot collection, this dot children, child container, this dot, maybe just this. So I could show you the marionette inspector, but the composite view is going to be listening to a bunch of things. You can probably see that in events. So show, render, destroy, those are all good. I think it's all listening to, I think it's listening to all as well. Those are those events. Oh. See, I was listening to all these guys. We can grab one of them. Does that work? No. It's really lazy. L, whatever. That event. Let me back up. I know that the collection views listen to all of its child views events. So I'm trying to unbind that. So basically, maybe I could just do that actually. This dot stop listening, and I just give it the object. Maybe I could do that. Yeah, so if you give it an object, I think it's just going to clean it up. So we can do L1. What that does. Are we now listening to L11? 76? No, we're not. I mean, I don't know if that's smart or not, but like, something you can do, you can turn off all the events. I'm just gonna like skip this now because I'm thinking that like, I don't know, if you're somewhere deep into in a tree and you want to expand all your parents, like maybe you want to go up the tree that way. On the flip side, maybe there are a lot of events that are propagating unnecessarily. I mean, we did see that here somewhere. All this probably could go away. but fuck it. We'll leave that one for another day. We're at 3 seconds. That's good enough. Oh, comment all this out. I kind of like this code. I know most people just delete it, but what I'm going to do is just drop it into a util, so it's easy to get back. Call this I don't really care, like we're not executing this code right now, but it's good to have around. So it's here. If everyone wants to use it, they can. I'm sure it'd be nice for more audits down the road. All this stuff, region, is that important? Target can definitely go. That's pretty clean. Let's just refresh. And if it passes, we'll be good. What else did we do? That might have been it. It was like those two optimizations. Activity. Still pretty fast. Alright, good. I like seeing the commit in here too. GitHub usually has a good way of just like consolidating what you already know. Yeah, about 58 additions with the collapse changes. And then, oh, we memoized the region tree. We should probably mention that. And then template cache. So it was like 3 things. And we add this down mutation server. Alright, cool. Anyways, thanks for sticking around. This was a lot of fun. It was very different than the first screencast where it was just a lot of feature development. This time we didn't really know what to do when we got in there, but we were able to find a bunch of things that could make it faster. And I hope you picked up a couple tricks along the way. See you next time. Bye-bye.